Okay, so for the second question, what we're dealing with is the limit as cos. So it's a strange looking limit, but it's a familiar one. So first of all, let's start by asking, does anybody recognize kind of what this might look like to you? What does it sort of resemble, or what might it sort of hint to you?
0 over 0.
A 0 over 0. Okay, but what else did we use limits that looked really close to this? Not L'Hopital's rule.
Cosine thing.
Sorry?
The cosine thing, there's this cosine.
It's funny because we've been doing them for so long, we've all forgotten the very basics of it. This is very close to the definition of a derivative. One thing I could do is I could write this as cos pi over 2 plus h. And I'm going to add to it the cosine of pi over 2. And all divided by, I'm going to subtract. That should be a minus sign. Subtract from it the cosine pi over 2 and put it over h. Cosine pi over 2 equals 0. I'm not taking anything away from this. I'm just trying to show you what it looks very close to what we've already worked on. Do you recognize what this is? Nope, it's been a while. This is the definition of the derivative for the cosine of pi over 2. This is the same thing as asking what is the derivative at sine. Okay, so it most closely resembles the derivative. And remember, if you think about what this picture means, here is the graph for cosine. Okay? And what we're saying is, here's the point cosine pi over 2. I've got some other point, maybe it's here, and it is moving towards that point. So top minus the bottom divided by how much the difference in x was. This distance here, this is h. So I'm actually doing the slope formula, right? I'm making this secant line, which right now looks like this, turn into the tangent line, which will eventually look, something close to that. Okay, so, you want to try to recognize those cues because the original intention of this question was to see if you recognize the definition of derivative. Okay, so the reason I'm bringing this to your attention too is this is a pretty quick question. If you recognize the definition of derivative, this is the only work that you needed to do to answer it, which is pretty quick. Okay, so if that wasn't you and you didn't see it, you need to make a little note to yourself. That could be a question that saves you some time knowing the definition of derivative. Did anybody do this with L'Hopital's rule? Okay, so if we did it with L'Hopital's rule, which again is, I told you it would be handy, but it's not necessary. If we did it with L'Hopital's rule, pi over 2 plus h divided by h, it's a 0 over 0, which is L'Hopital's situation. So we take the derivative, and I'm going to have the limit as h goes to 0 of negative sine pi over 2 plus h times the derivative of the inside, which is just going to be 1, divided by the derivative of the bottom, which is now 1. Okay, so h becomes the 1. That's the derivative of the bottom. That's the derivative of the top. So this will be just the negative sine of pi over 2 plus 0, which is the negative sine pi over 2, which was the same answer I had before, which was negative 1. So it could be done either way, whether it was L'Hopital's or was definition of derivative. Okay, so in this, there is a quick way to answer this question as well. Really, again, relies on how quickly you can bring that knowledge back. So the first thing says f prime of 0 equals 5. The other one says f of 2 is less than f of 6. And then the last question, it says f is concave up. So, how do we figure out if the first one is true or not? Do you see the connection between f and f prime here? do we figure out the derivative of f if we know how to get its integral? Anki, did you manage to answer this question? Okay. Justin, you want to? Yeah, if we want to know the derivative, right? The derivative of an integral is just the function that's left behind. So f prime is going to be 10 over 1 plus e to the x. Oops, there's no dx anymore. We're not in the integral. Okay, so if we want to know f of 0, that means f prime of 0 is going to be 10 over 1 plus e to the 0. That's worth 1. So that's 10 over 2, which is 5. So yeah, that's true. Okay. So how do we know if the function is bigger at 6 than it is at 2? How could we know that? Or what does that imply about the graph? If you know that starting at 2, you have to go and up to 6, what had to happen in the middle? It's almost so obvious it doesn't. It could be, but it could still. There's part of concave down that could do this too. It has to increase, exactly. It has to increase. So if increasing, what does that mean? How do we know if it's increasing? How can you tell if a function is increasing? Yeah, first derivative is positive. So that's what we want to know. Is the first derivative greater than 0 from 2 to 6? Let's take a look. Up here, that's a positive, and e to the x, that's always greater than 0. So you got all these positive numbers. No matter what you do to them, you can't become negative. That is true. It's got to increase. No matter what number I put in, it's positive.
So we say that f of 6 is bigger than f of 3 because it's increasing, because it's positive.
Yes, because the derivative is positive, it's increasing all the way.
Right?
Okay? Now, f is concave up. How do you know if it's concave up? Sure, Nick, go for it.
You don't continue on because in your option, you don't have an option for 1, 2, and 3.
Okay. That's a good strategy. There's no 3, 1, 2, and 3 in your answers. But just in case you didn't see that, how can we find out if this is concave up or not? Second derivative. Good. So I'm looking for f double prime. So I like your thinking, Nick. That's good. But let's verify it real quick. 1 plus e to the x to the negative 1. That means if I take the derivative of this, I'm going to be at negative 10 times 1 plus e to the x to the negative 2. Derivative of the inside is e to the x. So here's what I do is I look at my pieces. This piece here, it's always going to be negative. This piece here is always going to be positive. 1 plus e to the x will be a number greater than 0. E to the x, that is always a positive. So you take your 3 factors, a negative times a positive times a positive. The result is always going to be, negative. So it cannot be concave up. This one does not work. So it could be 1 and 2 as the only possibility. The choice, I believe, is D.